In the extension for 5.1, we're looking at relations and functions, which are very closely related, but they're not exactly the same thing. So our learning goal, I will determine whether relations are functions and I will use the vertical line test to determine whether a graph is a relation or function, or whether a graph represents a function. So starting off with this, a relation is going to be any input paired with outputs. So a relation is just pairing inputs with outputs. And then let's go back and remember our definition of a function. A function said that each input has only one, or exactly one, output. So let's think about this. A relationship or a relation is just inputs and outputs. As long as each input has an output, you're good. But a function, each input can only have one output. So I'm going to show you some examples just to differentiate between these. So for our first example, we're going to look at 3 different types of situations. First, we're going to have, let's look at points. So if you're given these points, 0, 2, 1, 4, 2, 6, and 2, 7. Let's think about our domain here, or our inputs. Our inputs are 0, 1, and 2. Our outputs, or our range, would be 2, 4, 6, and 7. So here, each input does have an output. So this is a relation. Definitely a relation. But for a function, each input has only one output. When I put in 0, I get out 2. There are no other zeros to worry about. When I put in 1, I get out 4. There are no other 1s. When I put in 2, I get out 6. Or when I put in 2, I get out 7. That means 2 is paired with 6 and 7. When I put in one input, I'm getting 2 different outputs. So function, this is not a function. If you think about it, a function is kind of like a vending machine. You walk up to the vending machine, you push button 1, you better get whatever's behind, you better get the Reese's. But if you push button 3 and you get out a Twix and a Snickers, that is not a functional machine. The machine is not working. Each button needs to go to just one type of candy for a vending machine. So functions really work the same way. When I put something in, I can only get one thing out. Otherwise, it's not a function. So we could still have a relation without being a function. We can also look at this if we're looking at a table of input and output values. So looking at this table, we'll decide if something is a function or not. So -2, -1, 0, 1, 2 will be my inputs. And my output will be 2, 1, 0, 1, 2. So let's decide if this is a relation first of all. Well, each input here has an output. So we've paired up inputs and outputs. So this is a relation. But let's see if it's a function. -2 only shows up once. So -2 matches with 2. -1 goes to 1. 0 goes to 0. 1 goes to 1. 2 goes to 2. So every input has only one output. So this is also a function. Now you might look at this and you might say, oh, but look, -2 goes to 2 and 2 goes to 2. That's okay. Remember, it's my inputs that can have only one output. There's no rule that says every output needs its own input. So, if we go back to the vending machine example, there might be 3 rows of Snicker bars. So it doesn't matter if you push button 1, button 2, or button 3, you get a Snickers bar. What does matter is that when you push button 1, you're only getting one kind of candy out. So this is a function because each input has only one output. There's one other way, well, there are 2 other ways. There's a graph, but then there's also one other way to look at this, just visually without the graph, which is, it's called a mapping diagram. So we have our inputs here, our output here. And so what a mapping diagram does is it shows us when I put in 2, I get out 10. When I put in 4, I get out 5. I put in 4, I get out 15. When I put in 6, I get out 15. So, first, to check if it's a relation, does every input go somewhere? Yes, it does. So this is a relation. Every input has a partner output. What I need to look for next, though, does each input go to only one output? Well, 2 goes to 10 only, but 4 goes to 5 and 15. So this is not a function. So it's pretty easy to decide if you have a relation or not. All of these were relations because they all had pairs of inputs and outputs. Just real quick, if I added a 7 right there, and that 7 didn't go anywhere, this would no longer be a relation because 7 doesn't have a buddy over here. So that's what it would look like if it's not a relation. But for all of these, every input had an output. However, they didn't all have only one output. Remember, up here 2 went to 6 or 7. Down here 4 went to 5 and 15. So both of those were not functions. A final way to determine if something is a function or not is to look at the graph. So here I have 2 separate graphs. And what we do is we can use something called the vertical line test, which basically means if you took a vertical line and you run it along your graph, that vertical line should never intersect the graph in more than one place. So if I look at this purple graph, I take my vertical line, and you'll see that as I go along, I'm only intersecting that graph in one place at a time. But if I look at my red graph, as I take my vertical line, you'll see like right here, I'm intersecting up here, and I'm intersecting down here. I'm intersecting in more than one place. So if at any point on your graph, your ruler hits more than one spot on the graph, then you have just a relation. It's not a function. And if you think about it, remember your range or your output values go with your y's. So what this is saying, like at this point right here, when x equals, how about -3, I'm getting out 4 and -3. So I'm putting in one number, I'm getting out 2 values. So that's really why your vertical line test is going to work. So this would be a relation, but not a function. And my purple graph over here, this is a relation, and it's also a function. Each input had only one output. So that's one more way you can look at something and decide if it's a function or not.